All right, welcome back to Lag Demon Programming. I'm Bill Westlake, and we are working on compiler design. In the last video, we created a tuple and a list, and in this video, we're going to start working on custom types that the user can define, the programmer can define in the program. And the first type we're going to work on in this video is a record type. But before we actually start working on the type, we're going to make a little bit of a modification here to this identifier, which we've got just as a sim up here. So if we go all the way up here, we find a sim can be A to Z or underscore at the beginning. And I'm going to change that and say that the very first thing, I'm going to change this to a star, so it can be any number or 0, and we're going to put just A to Z, so that regular symbols have to start with a lowercase character. Oh, no, A to Z plus, or A to Z, yes, plus, have to start with a lowercase symbol. They can have more lowercase, but it has to have at least one. Actually, you know what? We could make this 1 because we got the A to Z in the next one. So we can make this, there has to be at least 1, and then it can be followed by more lowercase and uppercase and underscores, but it also cannot start with an underscore. And then we're going to make another one here, which we're going to call it a type sim. And it's going to start with A to Z, at least 1. And then it's going to have all of the rest of this. So why am I doing that? Well, types are going to be at least one uppercase letter at the beginning, and regular symbols will be always lowercase at the beginning. So variable names, value names, and stuff like that, function names, will all have to start lowercase. So we're going to create type sim down here. And if we have, type sim, it's going to be the same as this, except we're going to return, instead of ident, we're going to return type ident. All right. Back to the parser. We have to do a type for that. So we've got ident is a symbol, and percent token. This can also be a symbol, and it could be type ident. Okay. Now, having made that change, let's compile it and make sure that our thing here still compiles and doesn't find any weird errors. I don't think I used any uppercase, but if we were to go into here now, and we'll just put it at the end, we'll go let A equal 1, and we compile that, or run that. It put out a 1 at the end, and I'll bet we have an error up here, and we do. We have an error, unexpected type ident, expecting ident. So it saw this as it's expecting a regular identifier there with a let statement, but it got an ident instead of a type ident. We'll work on better error messages at some point in the future. So let's just get rid of this. That's definitely working. Okay, parser.y. Now we have a type ident. So a couple of things we need to define first. We'll put this down here under our types. A couple of things that we need to establish. One, for our record, is what does a field look like? So what we're going to do is we're going to call this a record field. And a record field is going to be an identifier followed by a colon, followed by a type followed by a semicolon. That's a field in our record. And so now we have a record, which is going to be a type ident. Oops. We need a keyword. Almost forgot. Let's go back to our Lexer. Here is our keywords, and we're going to create a keyword type. And we're going to say return type T. And go back to our parser. We just need to create that token for that keyword. Go here, we'll go type underscore T. And all the way back down. A lot of scrolling. So we're going to have the keyword type T followed by a type ident, which is going to have to be uppercase, followed by an assign, followed by a O brace, followed by a what's going to become a record field list, followed by a C brace. That's our entire record. So, record field list is, we've done this many times, it's going to be a record field or a record field list followed by a record field. And that's that. All right. And then here's where it's going to get tricky, because a type can also be a type ident. And well, we've got record T is a type in this. So how do we want to handle this? So actually, instead of being a record T here, this actually needs to be just a record. And no, that's not going to be it. I'm going to have to think about that for a little bit while we go fill this other stuff in. We've got to turn these custom types into types. We've got record and enum here, which is the next one we're going to do as a record T. Let me see what a record T is. What did I do over here in the Lexer? Did I even make it? Oh, it's the keyword record. So we probably don't want that. Or enum. I was originally going to use keywords for these, but rather going to use syntax for them. So I'm going to take those out of there completely so I don't confuse myself. I'm going to go up here and get rid of record T and enum T from here. I'm going to go down to type. I'm going to get rid of record T and enum T from here. But I'm going to leave it in the types. Because we're going to do something with this once we get to that point. Okay, I'm back. Okay, so now we have to create our record in our AST. So we come over here to our AST, and this is a type definition, so we can just go down here to the bottom and we'll go class record colon FNG node. And what is a record going to need? It's going to need a field list. So what we'll need is a class called Yeah, we're going to need a class called a record field, which is going to be of type, it's not going to be a node, it's just going to be a record field. And what we will have in the record field is going to be an identifier, pointer, underscore ident, and it's going to have a types type then we'll have public record field identifier pointer ident types type underscore ident underscore type and we'll have identifier pointer get ident return underscore ident. We'll have types get type return underscore type. And this doesn't need a visitor because we'll handle that. This is supposed to be types. Then we'll need a type def. Record field, and that'll be a record field list. So this class then will have a record field list pointer called field list. It's got to have an identifier ident record identifier pointer ident record field list pointer field list. This should be lowercase. Field list. And then identifier pointer get ident returned underscore ident. This would be identifier pointer record field list pointer get field list return underscore field list. And then we need the usual accept. Okay. Visitor.h will need a we'll just copy. This is going to be a record pointer. We also have to go to the CPP. And we can change this, do this, and instead of list, this is going to be record. And Pretty Print needs to implement that. Let's go down here to the bottom. We'll start with, just do this. That's going to be record pointer node. We'll just take everything out of there for now. Okay. Back to the parser. Okay, we've got to do this record field list, and record. So we need to have a record field pointer, record field, record field list pointer, record field list. And we need to have a record pointer, record record, and then down again here. Let's just copy this. Record field, record field, record field list, record field list, and record as a record. Okay, so far so good. So we've got our record field. We need to go $$ equals new record field, $1, $3, and the record field is in. So this one needs to be $$ equals new record field list, $$ pointer push back, $1. Very repetitive, I know. This is what it is. So this is going to be $$ pointer push back, $2. No, yeah, almost. We got to move it. So we got to go $$ equals $1, then $$ push back. And here we'll do it down here because that's kind of long, and we'll go $$ equals new record, and it's going to be $2, comma, $1, 2. Okay, we'll do it with the mouse instead of my finger. $1, 2, 3, 4, 5. $5. Now, where do we stick in a record so that it gets processed as part of our types? So a type here can also be a record, in which case, but these are types. These are just returning those types. Oh, I know why. It goes all the way up here. A line can also be a Well, we'll say a record for now. And we'll say, $sign equals $1. And what didn't it like? st.h public now what doesn't it like? Oh. Okay. Yeah, lots of little subtle things here. This is a record field pointer. $1. Standard string. $2. Now what doesn't it like? Record. Oh, that's because I said it was an identifier, not a standard string. So, but it's got to be a type ident and not just a regular ident. So what we need to do here is go new identifier, $2. Oh, come on. New identifier, comma, types, colon, record. Record is not a matter of types. Oh, yeah, because it's all uppercase. Record. Ah, darn it. Hey, what do you know? It ran. So let's create a record. Let's say type my record equals, and we'll say A colon int semicolon B colon string semicolon C colon char semicolon D colon float semicolon ABCD. I think it compiled it, but we're just not doing anything. Maybe not ABCD. Why would it just print those out? Oh, probably because it saw the identifiers. Okay. Pretty print. So we want to do here is go standard cout from type from node pointer get ident pointer get ident standard cout from close brace, and then we'll do for auto n colon node pointer field list, standard cout from pointer and pointer get ident pointer get ident from colon from n pointer and pointer get type, but we need to go type to string around that, semicolon, and standard end to L. What's going on? Type my record equals open brace. No, not visitor. Where's my parser? Type ident assign O brace C brace. And a record is a line, right? Or a line, rather, is a record. And that's where it should be appearing. Should get that record, and it should process it. Did we miss something in the way we're handling our visitor? So we've got record. We've got record accept visit this. We'll be passing the pointer in. st h. It's a node. It's got the accept. And a pretty print. Doesn't appear to be being called. Okay, so when I ran into this before, it was because I didn't really handle this correctly. A record. Is with type T, a type ident, assign an O brace, a record field list. A record field, identifier colon, type, semicolon. Do I have those types? And that's what we are expecting here is a type. Right. A type by name. In here, a type. Int, string, char, float. Bool. Byte. Type my record equals okay, well, it looks like I'm probably going to have to cut this here and come back to this. We're almost there on doing a record. I just got to figure out why it's not capturing it correctly. Okay, I fixed it. It was a very simple mistake. Over here in the Lexer, I already had the keyword type, returning type, and I created the keyword type again, returning a different one, so it was passing this type in. So I simply eliminated the one I created, and over here in parser I eliminated that token from up here, so we don't have a separate type T. It's just type wherever it is in here somewhere. There's the keyword type. Where is it? There it is. The keyword type, that's the one we're using. Keyword type, and I just put keyword type in here, and we're good to go. And it builds, and we run it, and there's our record type. My record equals, and it picked up all our values and our types, and it created that object, and the pretty print prints it out very nicely. I also just cleaned that up a little bit. I had forgotten to do an indent on it. Where is pretty print? There it is. So I just threw in the push indent, and pop indent like we discussed before in making the pretty print look a little bit nicer. So that's the fix. Thanks for watching. I hope you enjoyed the video. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I really appreciate those subscriptions. And I will see you in the next video. Thanks for watching.